Okay, now a body is said to be in motion. So what comes before your mind's eye? Lago, Jora. Jora. Point. A point object of mass, and mark the point here on the paper and say it as mass m. So the position of the point is p1 and the time is t1. And then when I say it is in motion, then attach a velocity vector to that. Say call it as v1. Got it?
Yes, sir.
So this, when I say a body is in motion, then pata you should get this idea. Right? Then I will tell you, between time interval t1 to t5, say t1 to t2, okay, the velocity vector does not change. So t1 to, between time t1 to t2, the velocity vector did not change. Right? Velocity vector does not change. What does this imply?
So between that time interval, it was moving with uniform velocity.
That's all. Between the time interval, it was moving with uniform velocity. Okay, great. Why was it moving with uniform velocity?
So because it's not a
Because
there is no
the
action.
direction
No, I did not ask you what is uniform velocity. If I ask you what is uniform velocity, then you should say the speed of the body is same, the direction is also same. If I ask you what is uniform velocity, now I am asking you why it is moving with uniform velocity.
Sir, because force is no action.
No net force. No net force. Net force acting on the body. Right? Acting on the body. Understood?
Yes, sir.
That should be the answer. Okay? Okay, done. Now, from T2 to T3. Okay? From T2 to T3. Force F bar acts on the body. Force X bar acts on the body. Acts on the body. Okay? Then what happens? Yes.
The body will accelerate.
Yes, the body. You again told half answer.
Sir, velocity.
Velocity change. Your answer is correct. Half answer as usual.
Sir,
When
the body,
force, see, T2 to T3, force F acts on the body.
yes.
What is your answer?
Sir, the body will accelerate between time interval t2 to
T3. Here the Kangal. I am telling you, no, you should tell. So between time T2 to T3, the body will accelerate. Right?
Yes, sir.
It
Yes,
will
sir.
accelerate. Very good. Right. So, because why did it accelerate?
because velocity is
Sir,
See, what is acceleration? Then change of velocity is acceleration. Why it is accelerating?
Sir, because force.
That's all I wanted to tell. Because force is acting, it is accelerating. Because force is acting, it is accelerating. You listen to the question. Got it? Hello? Now, so there is force, right? Sorry. There is acceleration, there is force, and there is mass.
Yes, sir.
How are these three quantities related? There is force, there is a body, mass m, force f, and it is accelerated. So how are these three physical quantities connected, related?
So to find the
What is the relation between a bar, f bar, and m? Newton's second law. So a bar is equal to what? How much is the acceleration? If you apply so much force, how much acceleration will be produced? Isn't it?
Yes.
Force upon mass is acceleration. Or did I not teach you 10 times? Then what is the problem? See, if you apply force, the body is accelerated. If there is net force, the body is accelerated. So, how much force you applied? How much mass? More the mass, less acceleration. Did I not show you with some bottle there? Hello?
Yes, sir.
Then why it did not answer? Come on. So this is what you are not trained. So again today I will be teaching the same. You should come prepared. You should think about this. As soon as you go home, you should think. Before coming to the class, you must think. All these concepts, you should enter your ನರನಾಡಿಗಳಲ್ಲಿ ನಿಮಗೆ ಫಿಸಿಕ್ಸ್ ಗೋಚರಿಸಬೇಕು. ತಿಳಿತೀರಾ ಹೇಳಿದೆ? ನರನಾಡಿ ಅಂದ್ರೆ ಏನು? Your nervous system, your veins, your blood vessels, your nerves. Okay, in that this physics should flow. So how can it flow? Yeah, it will flow. You think properly. ಸೊ ನೀವು ಅಂದ್ರೆ ನರನಾಡಿಗಳಂದ್ರೆ ಈಗ ನನಗೆ ಏನಾದ್ರು ಕೇಳಿದ ಕೂಡಲೇ ನಿಮ್ಗೆ ಯಾವ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಟಕ 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 ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಕೊಡಬೇಕು, ಕರೆಕ್ಷನ್ ಕೊಡಬೇಕು, ಹೇಳಬೇಕು. ಈಗ ಹೆಂಗೆ ನೀನು ನಿಂತು ಮಾತಾಡ್ತೀನಿ ನೋಡ, ನೀ ಹೆಂಗೆ ಮಾತಾಡ್ತೀನಿ ನೋಡ. ಓಕೆ, ಸೊ ಡೂ ಯು ಥಿಂಕ್ ವಿಚ್ ವರ್ಡ್ ಟು ಯೂಸ್? ಪಟಾಪಟ್ ಯು ಟಾಕ್ ನೋ. ಓಕೆ, ನಿಮ್ಗೆ ಯಾರು ಬೈದ್ರು ಪಟಾಪಟ ಹೆಂಗೆ ಸಂಸ್ಕೃತ ಹೊರಗೆ ಬರ್ತಾವ? ಬರ್ತಿದ್ದಿಲ್ಲ ಚಲೋ ಚಲೋ ಸಂಸ್ಕೃತ ಹೋದ್ರು ಯಾರು ಬೈದ್ರು ಬರ್ತಾವಿಲ್ಲ ಪಟ ಯಾವ ವಿಚಾರ ಮಾಡ್ತಿದ್ರೇನ್ರಿ? ಯಾವ ಪದ ತಗೊಂಡು ಬೈಲಿ ಹೆಂಗೆ ಬರ್ತೈತೆ ಸಾಟ್ ಬರ್ತೈತೆ ಬ್ಯಾಗ್, ಹೌದಿಲ್ಲ? ಹಂಗೆ ಫಿಸಿಕ್ಸ್ ಬರ್ಬೇಕು, ಹಂಗೆ ಸಟ ಕಾನ್ಸೆಪ್ಟ್ ಇರಬೇಕು. ಸೊ ಯು ಹ್ಯಾವ್ acceleration, you have force, you have mass. So what is the relation between them? Acceleration is equal to force divided by mass. So it means more mass for the same force, less acceleration. For same mass, more force, more acceleration. Got it now?
Yes, sir.
Done. So till this point you understood? Hello? So the body got accelerated because of force. Now you see this force, I told there is force acting on the body. Right? There is force acting on the body. I told, correct?
Yes, sir.
Now you see, well now if I leave my hand, okay, if I leave my hand, now my hand is holding this body. If I leave my hand, okay, if I leave, observe and tell what happened. If I leave my hand, what happened?
The state of motion.
State of motion changed, then
It got accelerated.
it got accelerated. Then why did it get accelerated?
Because velocity.
See, again you are making the same thing. If I tell you what is acceleration, then you must say change of velocity. Why it got accelerated?
Force acted.
Then you should think and tell no, force acted. Now here, which force acted?
Gravitational force.
Understood now? So gravitation force acted. Okay? Now think and answer. For this body, I told force acts on the body, therefore it got accelerated from T2 to T3.
Yes, sir.
Correct?
Yes, sir.
Force acted on the body, therefore it got accelerated from T2 to T3. Correct?
Yes, sir.
Now, what force acted? You should use your common sense. Which force acted on the body? It got accelerated. See, think and answer. Rutvik. So I told between between T2 to T3, force F acts on the body. It got accelerated. What force acted on the body? I given a general name F. Correct. Now what is that F?
So net force.
Net force. What caused the net force? You think, your common sense, what does it say? What caused? I told force F acts on the body. What is that force F? Why are you thinking? Don't think. Did I tell you gravitational force? I didn't tell. Did I tell you frictional force? I didn't tell. Did I tell you spring force? I didn't tell. Did I told you it is the buoyant force? I didn't tell. Did I tell you spring force? I didn't tell. Did I tell you Coulomb's force? I didn't tell. Did I?
No, sir.
Understood now? But I told you some force is acting. Got it, all of you?
Yes, sir.
I told you some force acting. So therefore, what is the tatparya of this? Understood now? So what is the tatparya of this? What is the inference? When we are discussing here, when I say force, it can be any force. It can be any force. Got it? Not specifically this one. That means this theory what I am developing here, this equation what I am writing here, okay? In general, it says it is force. Okay? Yesterday we saw that you had a surface. Okay? So from here to here, it was smooth. Okay? And from here onwards, it was rough. So here, if you keep a body here, okay, and if you push this body will start moving with velocity v bar. You remember?
Yes, sir.
And how will it move from this point to this point? Louder. It moves with uniform velocity by.
Because there's no force to opposites.
Yes, there is no force to opposite. Fantastic. There is no force to oppose, there is no force to affect. It can be opposition or proposition. So no force acts between these two because it is smooth. Yes. And here onwards, what happens to the velocity of the body?
So the velocity of the body decreases.
Yeah, definitely it decreases. And now, why does it decrease? Velocity, why does it decrease?
So that's a
Sir,
force that
There is a force acting opposite to the velocity vector. See, you should tell it to. Now, if I ask you which force,
Friction.
that is what you have to tell. Because here it is very clear.
Yes, sir.
Understood? Then when I leave this body, why did it accelerate? You know for sure it is gravitational force. Got it? So you should start using common sense and science. Okay? Refine your day-to-day thinking process using the scientific terms. And that is nothing but learning science. That is nothing but learning science. Understood? Science is nothing great. Your grandmother knows more science than me. If you go to the kitchen, she knows better science than me. Isn't it? She will manage everything. She knows how to use heat, temperature, etc. Right? So, but of course, if you ask her, she will tell in her own terms. She might not use the term temperature, heat, pressure, specific heat, all those terms she will not use. We will use those terms and make it perfect because we want to engineer. We want to use those science for something else. That's why we are learning all this. Okay, so now you have identified how many forces? How many forces? Gravitational force?
Normal.
Gravitational force and then frictional force. Correct now? Any other force have you come across now?
contact force.
Where have I told you contact force?
Property of frictional force.
First property of?
Frictional force.
Where did I use the first property of frictional force?
So yesterday I told when two bodies when two bodies are in contact.
Then, see, now don't confuse. I asked you what is friction. So to answer what is friction, see, friction will not happen somewhere. For friction to happen, certain conditions are necessary. Got it now? See, for something to happen, some conditions are necessary. Okay? So what are the conditions for frictional force to come? The two bodies must be in contact. There must be relative motion, or there must be attempted relative motion, and then there must be a force to oppose the relative motion. Then this force is called frictional force. Got it? See how I am telling. First, there are set of conditions. If this set of conditions are satisfied, then you get the concept of friction. If these set of conditions are satisfied, then you get the concept of friction. If one of these conditions are not satisfied, then you will not get the concept of friction. There is no concept of friction. Correct?
Yes, sir.
So here I have used the word contact because the two bodies come in contact. Clear?
Yes,
sir.
Done. Okay. Now my dear friend used the word contact force. He used the word what?
Contact.
Louder.
Contact
force.
Contact force. Contact force. Correct? My good friend used the word. Physics is very simple. The names used here means it automatically gives the meaning. Contact means what? They come in contact. The two bodies touch. That is what we call it as contact. Correct? Now you see. Now if I leave my hand, what will happen? This pen will fall. So this is called free fall. What is called free fall? You leave your hand, the pen is moving without any force, without only gravitational force is acting. No other force is acting. Got it? So it is gravitational free fall or simply free fall. Got it?
Yes, sir.
Nice, no? Do you imagine something freely falling which gives you a lot of happiness? When my teacher was torturing me like this, I imagined my sir should be freely falling. Chalo? Who know? Of course, so understood free fall. So this is undergoing free fall. Correct? Free fall. Okay. So it undergoes free fall. Now you see there is one surface. If I do like this, that means it is a rigid surface. This is rigid surface. This wall is rigid. Understand? So I will show a rigid surface like this. Okay? Now a body comes in contact with this. A body comes in contact with this. Okay? See? Now this table is this. Right? On this table I will keep this pen. Okay, wait. So there is a surface, hard surface, and then so there is a hard surface. On this, I am keeping a body.
Yes,
Now you see, if I keep this body in Hava and leave my hand, what happens? If I leave my hand, this body will freely fall. But now, its free fall is arrested. What did this table do? Its free fall is arrested. Got it now?
Yes.
Its free fall is arrested. Did you get the capture the meaning of arrest? Hello?
Yes.
What did this table do? It arrested the free fall. Got it? Arrest andre bare police arrest mododalla. This is also called arresting the free fall. Basically, arrest means the person has made a crime or he has done something unlawful, and therefore he is curtailed from doing anything else. That is what is called as arresting. So now this body is arrested. Its free fall is arrested. Got it?
Yes, sir.
So now this is the condition. What you see on the board. What you see on the board is what you see on the board. So now let us understand. See, this body when it was in the Hava, in the air, okay, it was freely falling, right? And it was accelerating. This body was accelerating, and it was freely falling. And all of us know there is gravitational force acting on the body. And this gravitational force is the mass of the body into acceleration. See, I told you F is equal to m into A. Newton's second law. Force is equal to mass into acceleration. So here F is equal to m into A. Hello, got it? That is the force acting. But now here this force is something special force. What is special force? It is gravitational force. क्या बोला मैंने? ಈಗ ಒಂದು ಮಜಾ ನೋಡಿ ಒಂದು ಅರ್ಥ ಮಾಡ್ಕೊರಿ ಅಲ್ಲ ರೆಡಿ ಸ್ಟಡಿ ಕೋ ಈಗ I will telling you what is acceleration. I will telling you what is acceleration. Okay, so try to understand this acceleration. See, at this point the velocity of the body is v1 bar. A body is really falling.
Yes, sir.
And it is time is t1. Right? Now the body is falling. It is here. What is this here? It is at point P1. It is at point P1. Right? Then I leave my hand. It will come to point P2, P3, P4, P5 like this. So from P1 it will come to point P2. Correct?
Yes, sir.
It will take some time. It will take some time, T2. And here its velocity, as you see, is more than the velocity here. Correct?
Yes, sir.
V2 bar. Got it? Now what I do here, you see. Instead of writing T2, I will write T1 plus 1 second. T1 plus 1. T1 plus 1 second. Got it?
Yes, sir.
So what did you understand when I wrote the body was here, it came here. How much time did it take to come from here to here?
1 second.
Louder.
1 second.
Understood now?
Yes,
It has
sir.
come 1 second. It has come 1 second. Okay? So in 1 second, the velocity changed from V1 bar to V2 bar. Hello?
Yes, sir.
In 1 second, its velocity changed from V1 bar to V2 bar. Correct? So it has got accelerated. It has got accelerated. And now how much is the acceleration here? V2 bar minus V1 bar divided by 1 second. Change in the velocity divided by time to change. Got it?
Yes, sir.
Here 1 second means anything divided by 1 is redundant. Got it now? Hello?
Yes, sir.
Now I will tell you something. Supposing at this point the speed of the body was 1 meter per second. Speed. ಯಾವ್ದೇ ಒಂದಾನಂತ ಕಾರಣ ಹೊಂಟಿದ್ವಿ ಸ್ಪೀಡ್ ಅಂತ ಕೇಳಿದ್ವಿ ಸ್ಪೀಡ್ ಏನ್ ಸ್ಪೀಡ್ ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ ಸ್ಪೀಡ್ at time t1 its instantaneous speed is 1 meter per second. Hello?
Yes, sir.
Now
Yes, sir.
good man. After 1 second what will be its speed?
Set in more.
Good. I like this answer. You are sure that it will be more, but how much more? That you don't know.
We don't know.
Sir, it will be more. See, that much truth you know. Satya ಏನು ಗೊತ್ತೈತೆ ಅಷ್ಟೇ ಹೇಳಬೇಕು. The one truth you know is it will be more. Okay? How much more? That you don't know. Got it?
Yes,
Hello.
sir.
Now all of you understand. If you leave your hand, whether it is this pen or whether it is this duster or whether you take Sudheer Murthy and leave his hand, got it? You'll ಖುಷಿ Sudheer Murthy don't ಬಿಟ್ಬಿಟ್ರು ವಸ್ತಾರ. So if you take this pen and leave, if you take this duster and leave, or if you take Sudheer Murthy and leave, and supposing Sudheer Murthy, pen and duster are all here, its velocity is given back, and it is at point P1. At time T1, Sudheer Murthy, pen, duster all have got velocity 1 meter per second. Then you leave your hand. You see after 1 second they will be here. Hello?
Yes, sir.
And they will be having velocity V2. They will be having velocity V2 bar. You will see that the velocity of this will be 1 plus 9.8 meters per second. Its velocity will be 1 plus 9.8 meter means how much? 10.8 meters per second. Got it? ಅಲ್ಲಿ ಏನರ್ಥ ಆತ? 1 second ಒಳಗ velocity increased by 9.8 meters per second. ಅರ್ಥ ಆದಲ್ಲ? 1 second ಒಳಗ velocity increased by 9.8 meters per second. Got it?
Yes, sir.
So this is what happens when you leave a body in space. Whether you leave duster, pen, pencil, rubber, Sudheer Murthy, anything you leave, they will all change in 1 second by 9.8 meters per second. Their velocity will change by that much. It will not be more, it will not be less. Got it?
Yes, sir.
Now, at time T1 plus 2 seconds, the body will be here. Its velocity will be V3 bar. Got it?
Yes, sir.
So what will be the velocity here?
Sir, 10.8 plus 9.8 meters per second.
Exactly. So 10.8 plus
Plus
9.8 meters per second. Got it?
Yes, sir.
Yes, sir.
So 20.6 meters. Understood?
Yes, sir.
So here you see, the velocity is changing by 9.8 meters per second every second. क्या बोला मैंने? बोलो.
Velocity 9.8 seconds
The velocity of the body
of the body.
will change by 9.8 meters per second every second. So that is why the unit of acceleration will be meters per second per second. So that will become what? Meters per second. Meters per second. And for if a body is falling under gravity, then the acceleration will be 9.8 meters per second. The acceleration of a free falling body will be how much? 9.8 meters per second. So what does it mean? The body is accelerating at 9.8 meters per second square means what? Means what? Just now I told you. If the acceleration of the body is 9.8 meters per second square, what does it mean?
Sir, for every second, the speed of the body will increase by 9.8 meters per second.
Yeah, IIT Bharati, correct. Mark my words. This is what I am testing in all of you. Every second, the speed of the body will increase by 9.8 meters per second. Understood? No? See, this will no, you if you say you have understood, I will ask like that. Then you should be able, if you have understood the concept of acceleration, whichever way I ask, you will tell the answer. ತಿಳಿದಲ್ಲ? ಹಂಗೆ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಬೇಕು ನೋಡಿ. ಅವ್ನು ಹೇಳಕ್ ಬರ್ತಾ ನಿಮಗೂ ಹೇಳಕ್ ಬರಬೇಕು. ಯು ಕ್ಯಾನ್ ಆಲ್ಸೋ ಡೂ. ಒನ್ ಥಿಂಗ್ ಈಸ್ ವೆರಿ ಬ್ರೇವ್. ಉಡಾಳದನವ ಬ್ರೇವ್ ಅದ. ತಿಳಿದಲ್ಲ? ಸ್ವಲ್ಪ ಯಾರ್ಯಾರು ಉಡಾಳಿಲ್ಲ ಉಡಾಳ ನೀನು ಸ್ವಲ್ಪ ಉಡಾಳ ನೀನು ಆಗ್ತಿಲ್ಲ ಸರ್ ಬಂದು ಸಾಲಾಗ ಬಂದು ನೋಡಿದ್ರು ಅಂತ ಹೇಳ. ತಿಳಿದಲ್ಲ? ಸಿ ಚುರುಕ್ತನ ಬರಬೇಕು. ಸೊ ಇಟ್ ಇನ್ಕ್ರೀಸಸ್ ಮೈ ನೆಟ್. ಸಿನ್ಸ್ ದಿಸ್ ಇಸ್ ವೆರಿ ಅಂದ್ರೆ ಒಂದು ಯೂನಿಕ್ ನಂಬರ್. So we will call it as acceleration due to which force? Due to gravitation. So we will call it as acceleration due to gravity. Acceleration due to gravitation, we simply call it as acceleration due to gravity. Got it?
Yes,
So we will assign a special symbol G. What is G? Acceleration due to gravity. ಅಂದ್ರೆ ಇಲ್ಲಿ ಕಲಿಸಬೇಕಾದ್ರೆ ಇಲ್ಲಿ ಬರೆದಾಗ G ಅಂದ್ರೆ acceleration due to gravity ಅಂತ ತಿಳ್ಕೋಬೇಕು. ತಿಳಿತಲ್ಲ? And what is its value?
9.8.
Yes, 9.8 meters per second. ಈಗ ಯಾರ್ದೋ ಹೆಸರು ಇರ್ತೈತಿ. ಓಕೆ, ಅಶೋಕ್ ಜಿ ಮೂರ್ತಿ ಅಂತ. ಜಿ ಅಂದ್ರೆ ಅಶೋಕ್ ಗ್ರಾವಿಟೇಷನಲ್ acceleration due to gravity ಮೂರ್ತಿ ಅನ್ನೋಂಗಿಲ್ಲ. ಇಲ್ಲಿ ಜಿ ಅಂತ ಬರೆದ್ರೆ you should know what it is. Got it? Very good. So now see, so the force acting. So if I leave this body, what is the force acting on this body? Mass is m. Mass of the body is m. Into acceleration. What is the acceleration? G. What is mg? The force acting on a free falling body. Hello.
Yes, sir.
And
Yes, sir.
what is this? This is the acceleration. This is the force acting. What is this? Force acting on a free falling body. Aita? Or the force, gravitational force acting on a body. It need not necessarily be free falling. See now, if I keep this body here, right? So now what is the force on this duster?
Nothing, sir.
Loud.
Nothing, sir.
Net force is 0 ಅನ್ಬೇಕಾ? ನಥಿಂಗ್ ಅನ್ಬಾರ್ದು. ನಾನು ನಥಿಂಗ್ ಅನ್ನೋದು ಎಲ್ಲ ಕಲ್ಸೇನೆ. See, ಇದೇ ಡಿಫರೆನ್ಸ್. Ordinary person will say nothing. Physics student will not use the word nothing and all. ತಿಳಿದಲ್ಲ? ತಲೆಯಾಗ ನಥಿಂಗ್ ಅಂದ್ರೆ ನಥಿಂಗ್. ತಿಳಿದಲ್ಲ? ತಲೆಯೊಳಗೆ ನಥಿಂಗ್ ಶಗಡಿ ತುಂಬಿದ್ರೆ ನಥಿಂಗ್. ಇಲ್ಲಿಕ್ರ ಇಲ್ಲ. So what is the force acting on this duster?
Net force is 0.
Can you identify the forces acting on this duster? See here, I am holding it like this. Can you identify? Net force means there are some forces. The sum total of the forces is 0. Got it now?
Yes, sir.
So what are the forces acting on this duster?
Contact.
ಏನು ಕಾಂಟ್ಯಾಕ್ಟ್ ಐತಿ? ನನ್ನ ಹ್ಯಾಂಡ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಐತಿ. ಇದು ನೋಡಪ್ಪ, ಇದು ನನ್ನ ಹ್ಯಾಂಡ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಅನ್ಬೇಕು. ಬಿಡು, ಈಗ ಕರೆಕ್ಟ್, ನೀವು ಹೇಳೋದು ಕರೆಕ್ಟ್ ಐತಿ. ಈಗ ನಾವು ಟೆಲ್ ಮಿ, ಡೋಂಟ್ ಯೂಸ್ ದ ವರ್ಡ್ ಕಾಂಟ್ಯಾಕ್ಟ್. ವಾಟ್ ಆರ್ ದ ಫೋರ್ಸಸ್ ಆಕ್ಟಿಂಗ್? ಸಾರಿ, ಹಿಂಗೆ ಹಿಡಿದೆ ನೋಡಿ ಡಸ್ಟ್. ಕಾಣಿಸ್ತೈತಿ? ಹಿಂಗೆ ಹಿಡಿದೆ. Now what are the forces acting on the duster? See, what are the forces acting on the duster? ಯಾರು ಜಗಾಕತ್ತಾರ ಇದನ್ನ?
No, sir.
ಅರ್ಥ ಜಗಾಕತ್ತಿಲ್ಲ? ಅರ್ಥ ಜಗಾಕತ್ತಿಲ್ಲ ನೀವು? ದನಗಳು? ಹೇಳ.
Gravitation force and normal force.
ನಾರ್ಮಲ್.
Gravitation.
Gravitational force is acting. One force is gravitational force. Sure.
Yes.
So ಈ gravitational force ಆಕ್ಟ್ ಆಗ್ಲಿಕ್ಕೆ ಅದು ಬೀಳ್ಬೇಕು. ಆದ್ರೆ ಬೀಳಾಕತ್ತಿಲ್ಲ ಅಂದ್ಮೇಲೆ ಅರ್ಥ ಏನ? Some other force is acting opposite to that.
Yes, yes.
एक ऐसा खींच रहे, ये दूसरा फोर्स ऐसा खींच रहे,
Yes.
इसलिए ये कुछ नहीं हो रहा है उधर नीचे. ठीक है ना? नेट फोर्स इज 0. ठीक है ना? हाँ, अभी देखो नॉर्मल फोर्स जब आता है जब ये बॉडी कांटेक्ट होता है. अब दो फोर्सेस एक्ट हो रहे हैं. कौन सा फोर्सेस है? एक ग्रेविटेशनल फोर्स है, एक नॉर्मल फोर्स. जब ये बॉडी कांटेक्ट हुआ, कांटेक्ट का मतलब this surface should touch this surface. Then there are two forces acting. Gravitational force will always act, whether it is here or here or here. Gravitational force, because Earth's job is very simple. What will Earth do? Yena adra hatra irli jaggesh. Earth is jaggesh. Yena irli adra hatra kal, man, shagani yenidru jagde. ಹೌದಿಲ್ಲ? ಸೊ ಅದ್ರ ಕೆಲಸನ. ಸೊ gravitational force will act. But now this free fall is arrested by this table. So the moment this body comes in contact with the table ಏನ ಒಳಗೆ ಹೋಗಕ್ಕೆ ಬರಂಗಿಲ್ಲ, ಯಾಕಂದ್ರೆ ನಾವು ಮುರಿ ಹಾಕ್ಬಿಡಂಗಿಲ್ಲ. ಟೇಬಲ್ ನಾವು ಹೊರಗೆ ಹೋಗಕ್ಕೆ ಬರಂಗಿಲ್ಲ, ಮುರಿ ಹಾಕ್ಬಿಡಂಗಿಲ್ಲ ನೀನು. ಸೊ ಇಟ್ ವಿಲ್ ಅಪೋಸ್ ದಟ್ ಫೋರ್ಸ್ ಅಂಡ್ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ನಾರ್ಮಲ್. ಸಿ, ಈಗ ನೀವು ನಾರ್ಮಲ್ ತೋರಿಸ್ ಲೇಟ್ ಆಗಳೆ ಅಂತ ಕೇಳಿದ್ರೆ ತೋರ್ಸಕ್ ಬರಂಗಿಲ್ಲ. ತಿಳಿದಿಲ್ಲ? ಈಗ ಇದು ಪೆನ್ ಅಂತ ತೋರಿಸ್ಬೋದು, ಇದು ಲೆನ್ಸ್ ಅಂತ ತೋರಿಸ್ಬೋದು. ಬಟ್ ನಾರ್ಮಲ್ ಫೋರ್ಸ್ ನಾವು महसूस ಮಾಡಬೇಕು. महसूस ಅಂತ ಹೇಳ್ತಾರಲ್ಲ, हिंदी ಬರ್ತಿದ್ದಿಲ್ಲ, आपको नॉर्मल फोर्स महसूस करना पड़ेगा. कैसे महसूस करेंगे? देखो यार, इसको छोड़ा तो ये नीचे आता है. इसका मतलब क्या? ग्रेविटेशनल फोर्स तो एक्ट हो रहा है. ये ग्रेविटेशनल फोर्स एक्ट हो रहा है, लेकिन ये बंदा अरेस्ट होके रेस्ट में आ गया. तो कैसा आता रेस्ट? ये फोर्स एक है और दूसरा फोर्स इक्वल एंड अपोजिट होना ही चाहिए, नहीं तो ये अरेस्ट नहीं होता है कि नहीं. सो द नॉर्मल फोर्स मस्ट बी इक्वल एंड अपोजिट. मैं एक्सप्लेन करके दिखाया आप लोगों को. एक बंदा ऐसा खींचा तो इस तरफ चला गया, दूसरा बंदा ऐसा किया तो इस तरफ चला गया. दोनों बंदे पकड़ के मुझे सेम फोर्स अप्लाई किया तो क्या हुआ? मैं वेंकटरमणा बन गया, नहीं इधर दिस साइड नॉर दिस साइड. गॉट इट नाउ? नेट फोर्स इज 0. ऐसा हुआ ग्रेविटेशनल फोर्स ऐसा. देयर मस्ट बी सम अदर फोर्स which is applied by the surface of the body, and that force is normal. Normal क्यों बोलते हैं इसको? Normal क्यों बोलते हैं? देखो ये surface ऐसा है, and the force that is applied by the table is perpendicular to this body. That is why it is called normal. The force is not acting with angle. The force is perpendicular to. That's why it is called normal. Got it? So now on this body, what are the, on this body? Now I'll take you to the next one. Huh? So what you see here is one table. Table. Right? Now I have the body here. What are the forces acting on this body? Only gravitation.
Yes, sir.
What is this gravitational force? M into G bar. What is the net force on the body? See, what is the force acting, man, here? Gravitational force, no? So what is the force acting on this? Mg bar. So you, Hanmanta Bandhu. So F1 bar, F2 bar are like this. Okay? One experiment. Second experiment. F2 bar like this and F1 bar like this. We did these two experiments. So in this case, what is the net force? This force minus this force. Whichever is more, in that direction you will get. Correct now?
Yes, sir.
Now here, the other experiment we did was what? This force, this force. F1 bar, F2 bar. Now here you see this force and this force will simply get added. So what will be the net force here? F1 plus F2 will be the total force in this direction. Here what happens? F1 minus F2 in the direction whichever is more. Supposing this is more, it is in this direction. Now here F1, F2 is acting like this. Now what is the total force on the body? How to get the total force on the body? There is a technique. What is the technique? So you should draw a line parallel to this. See, this line is parallel to this line.
Yes, sir.
And to this force, you draw one more line parallel. So both of them are meeting at this point.
Yes, sir.
So from this point, you draw one. This force becomes net force. Got it?
Yes, sir.
This force becomes net force. This I have taught earlier. Got it now?
Yes, sir.
So this is called parallelogram law of vector addition. I taught you now.
Yes, sir.
Any questions here?
No, sir.
No, sir.
Okay, sit. ಈಗ ನೀವು ಆನ್ಸರ್ ಮಾಡಿದ್ರೆ ಮತ್ತೊಮ್ಮೆ ಇದೆಲ್ಲ ಕಲಿಸ್ತೀನಿ ನಾನು. ಹುಷಾರಿರಿ, ತಲೆ ತಿರುಗಿ ಚಕ್ಕರ್ ಬಂದು ಉಸಿರಾಡಕ ಬಿಟ್ಬಿಟ್ರಿ ಹೇಳಕ್ಬಿಟ್ರಿ. ಸರಿದೆ? ರೆಡಿ ಸ್ಟಡಿ ಪೋ? So now here you see. Now this is the body. Recording is on, man. This body is there.
Yes, sir.
Okay, this body is there. I leave my hand. Then what is the force acting on this body? How much is the gravitational force? Understood?
Yes, sir.
What is the net force on the body?
MG.
One force is acting, that force plus another force. See, in this experiment, I have shown two forces. Supposing I show this body with only one force. What is the force acting on this body? What is the force acting on this body?
F bar.
ಅದಕ್ಕೆ ಯಾಕೆ ಇದಕ್ಕೆ F bar ಅಂತ ಹೇಳ.
F bar.
What is the net force?
F bar.
ಅಷ್ಟೇ. See, that force plus 0 is that force only.
Yes, sir.
Got it now?
Yes, sir.
Net force ಅಂದ್ರೆ many forces if you add, total force is called net force. Got it? So what is the net force on this body?
mg1.
Got it?
Yes, sir.
So this body will start accelerating. And finally this body will come and, okay, this body is white color. So this body will come here. So when it touches the table, earth will not stop pulling. Earth will say, ನನ್ನ ಕೆಲಸ ಜಗ್ಗುದು. ಏನ್ ಮಾಡ್ತೈತೆ earth ಕೆಲಸ? ಜಗ್ಗುದು, ಜಗ್ಗೇಶ್. So earth will continue to apply this force. But here also it is applying mg. So but because of this force, this body is accelerated. But here it is not accelerated. That means this body is not accelerating. When a body is not accelerating, means what? Means what?
Sir, force is not.
Net force is not act. There is no net force. ನೀ ಬರೋಬ್ಬರಿ ಯೂಸ್ ಮಾಡು, ಅರ್ಧ ಯೂಸ್ ಮಾಡ್ತಿ, ಬರೀ ಅರ್ಧ ಮಾರ್ಕ್ಸ್ ಬರ್ತೈತಿ ನಿಂಗೆ. ಏನ? So this body is not accelerating. That means net force is 0. So for this force, there must be some other force equivalent. So this force plus this force is 0. Net force is 0. So this additional force is applied by the table on the body. So this force is called normal. Understood?
Yes, sir.
Yes, sir.
See that?
Yes, sir.
Yes, sir.
Okay. This is situation number 1. इसको क्या बोलते हैं? Situation number 1. जोश से कलिಬೇಕಾ ನಂಗೆ ಈಗ ಮಬ್ಬಗೆ ಕೂತ ಬೈದ್ ಬಿಡಬೇಕಷ್ಟೈತೆ ನನಗೆ. ಈಗ this is the condition of the body. You can see here.
Yes, sir.
Hello.
Yes, sir.
Yes, sir.
Yes, ಅನ್ನಾಕ ಒದ್ದಾಡ್ತ ಹುಡುಗರು. Right? So this body is at rest. What are the forces acting on this body?
Gravitational force and normal.
क्या बोला? तुम कुछ नहीं बोल रहे. Gravitational force and normal force. Can you see both the forces?
No, sir.
Say yes. With your normal eyes you cannot see. Divya Drushti. Now you are given Divya Drushti. Understood?
Yes, sir.
Divya Drushti ಗೊತ್ತೈತಲ್ಲ? Now you have got Divya Drushti. You can see the gravitational force and the normal force. Can you see these two vectors? Yes, you can see. And both are equal and opposite. So therefore this body is in a state of rest. Got it? Now you see, I am holding this. Can you see?
Yes, sir.
I am holding this and I am applying force. I am pulling it. I am pulling it this way. But is it moving?
No, sir.
No. Now we will do that analysis. We will do that analysis. So what we have got? We have got a table.
Sir, I want.
Okay. So on this table, this is dust. Got it?
Yes,
Yes,
sir.
sir.
Now what are the forces acting on this duster?
Gravitational force.
ಈಗ ಎಷ್ಟು ಚಂದ ಹೇಳಿದ್ರಿ, ನಾವೇನು ಹಿಂಗೆ ಬಂದು ಹೇಳು
Yes, sir.
ಇಲ್ಲಿಗೆ ನಾವೇನು ಇದನ್ನು ಕಲಿಸ್ತೀನಿ ನಾನು. This gravitational force and normal. And then what I did, I pulled it. I am applying force like this, some force, not more force. So how will I show that? So I will show that I have applied force. Hello, can you see?
Yes, sir.
Now how many forces are acting on this body?
3 forces.
Hello, louder.
3 forces.
Now this force is equal to this force. That means they cancel. They cancel. But this force is acting.
Yes, sir.
So because of this force, this body should have moved. मैंने pull किया. देखो, मैं आपके I will come and pull you. See now. See now. I am going to pull this chair. See here. I am pulling. I am pulling. If you want, come here. Pull. You want to try? Come. I will not hit you. I pull here. Gently hold this table here. Gently pull, gently. Salka, joralla, salka. You are pulling now? Then why is it not accelerating?
Because
Go sit there. I'll take you. Go. You experienced now?
Yes, sir.
So my dear friend Pritam is pulling one student who is sitting on the chair. One student is sitting on the chair, and another student came, held the leg of the chair, and he tried to pull. But nothing happened. That is the same situation there.
Yes, sir.
So on your student there are two forces acting, mg and n bar. N bar is given by R, mg is because of gravity. And then you came and pulled F bar. But now the body is unmoved. It's change. There is no change of motion. That means it is not accelerating. So what does it mean? It is not accelerating. It is not accelerating means what?
Sir, the mass of the body is very much.
It is not accelerating means what? When will the body accelerate? When will the body accelerate?
net force action.
When net force acts more. But ಅದು ಹೇಳಕ್ಕಿಲ್ಲ ನಾನು ಹೇಳ್ಕೊಟ್ಟೆ ಇಷ್ಟೊಂದು 5 ಗಂಟೆಯಿಂದ ಅದ ಕುಂಗಿಯುವುದೇನೆ ನಾಳೆ ಅದ ಕುಂಗಿಯುತ್ತೇನೆ ನೀವು ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಅನ್ನ ಕ್ರ್ಯಾಕ್ ಮಾಡೋದು ಕಲಿಬೇಕು ದ ಬಾಡಿ ಇಸ್ ನಾಟ್ accelerating means what? Net force is equal. Got it? Now you find out what is the net force of that body. So how will you calculate the net force of the body? How will you calculate? So total, what is net force? Sum total of all the forces. So this force is cancelled by this force.
Yes, sir.
So what is remaining? Only this force is remaining. Only that force is remaining. But the net force is 0. Means for when this force is acting, still the net force is 0. How is it possible? This force, see, you are pulling the chair.
Yes, sir.
So you are pulling the chair. But still the net force is 0. How is it possible? Or when will that be possible? See, now for example, you think that I am standing in a room. Can you imagine? Yes sir. Yes sir. Assume that I am standing in a room. Okay? So this is opaque. You can't see. Hello?
Yes, sir.
So
Yes,
so I am standing. So you will see only half of me. One ಕಾಲ ಇನ್ನೊಂದು ಒಳಗೈತಿ ಏನ ಇನ್ನೊಂದು ಭಾಗ ಒಳಗೈತಿ ನಂದು ಹೀಗೆ ನಿಂತೀನಿ ಇಲ್ಲಿ ಗಾಡಿ ಅದ ಬರೀ ಅರ್ಧ ಕಾಣಕತ್ತೀನಿ ನಂದು ಕಾಣತೈತಿ ಕಾಣಕತ್ತೀನಿ ಈಗ ನನ್ನ ಕೈ ಇದೆ okay right now here another student is standing here and he will now hold my hand and pull ಹಿಂಗ್ ನಿಂತೇನಿ ಅವ ಹಿಂಗ್ ಜಗ್ಗಾಕತ್ತ ಕಾಣಿಸ್ತೈತಿ ಅವ ಜೋರ್ ಪೈಲ್ವಾನ ಜೋರ್ ಜಗ್ಗಾಕತ್ತಾರ ಜೋರ್ ಜಗತ್ತ ಸೊ ಇಫ್ he jugs what should happen to me ಲೇ ದನ ಅವ ಜಗ್ಗಿದ್ರೆ ಏನಾಗ್ಬೇಕು ನಿಮ್ಗೆ ಏನಾಗ್ಬೇಕು ಹೇಳು what should happen? I am standing like this, somebody is pulling me like this. What should happen to me? Loud, you also shout.
Sir, you will move in that direction.
I will accelerate in the. Why start to use the word? He will accelerate in that direction. Must dance marti, correct? You will accelerate in that direction. Very correct. Hanga ಹೇಳ್ಬೇಕು. You will accelerate in that. Action marti. Very good. See, I want truth to come out. So if you pull me like this, I will accelerate in this direction. Isn't it?
Yes, sir.
That is what you see. Now I will tell you. Now you see that person is pulling me. Hello, but I am not accelerating. I am like this only. Even though he is pulling, I am like that. What can be the reason? See, this is the wall. You will not see. You will see only half of me. You see this person is pulling and I am not accelerating. Means what?
So another force is acting in opposite direction.
Another force is acting. So that means there can be one more person standing here and he might be pulling me. Correct now? Imagine ಮನಿ ಒಳಗೆ ಒಬ್ಬವ ನಿಂತಾನೆ ಹೋಗ್ಬೇಡ ಅಂತ ಜಗದ ಇಲ್ಲೇ ಬಾ ಹೊರಗಡೆ ಅಂತ ಬೇರೆ ವಿಚಾರ ಮಾಡಬೇಡ್ರ ಈ ನಿಮ್ಮ ಫ್ರೆಂಡ್ ಅಲ್ಲಿ ಆಟ ಆಡಕ್ ಹೋಗೋ ಜಾಗ ಅಲ್ಲಿ ಆ ಹುಡುಗನ ಅವ್ವ ಏ ಮಗನ ಮನೆ ಕುಂತ ಅಭ್ಯಾಸ ಮಾಡೋ ಜಾಗ ಆದ್ರೆ ಇಲ್ಲಿ ನಿಂತವಂಗ ಏನ್ ಕಾಣಿಸಕತ್ತೈತಿ ನಿನ್ ಫ್ರೆಂಡ್ ಜಗ್ಗಾಕತ್ತಿರೋದಷ್ಟ ಕಾಣಿಸಕತ್ತೈತಿ ಅದು ಖರೆ ಅಂದ್ರೆ ನಿಮ್ಮ ಒಳಗಿಂದ ಜಗ್ಗಾಕತ್ತ ಅದು ಕಾಣಂಗಿಲ್ಲ ಮಂದಿಗೆ ಏನಂತ ಜಗ್ಗಾಕತ್ತಿರ ಹೋಗಿಲ್ಲ ಅರ್ಥಲ್ಲ. ಸೊ ದ ನೆಟ್ ಫೋರ್ಸ್ ಇಸ್ ಝೀರೋ. ಕೊಡಿಟ ಹಂಗಾಗಿ ಇಲ್ಲಿ ಏನೋ ಆಗೈತಿ. ಸೇಮ್ ವೇ ಸಮಥಿಂಗ್ has happened here. You pulled your friend's chair like this. This force is cancelled by this force. So this force you are pulling, but still the chair is not moving. Means what? Means what? There must be another force which must be acting equal and opposite. Got it now?
Yes, sir.
There must be some force. See, you have to think like that. That is all. Now, where is that force? Between that body and earth. Understood?
Yes, sir.
So, this body is touching this body. This body is touching this body. And here the force is acting. Here acting, here acting. It is same like it is acting.
Yes, sir.
So, this force is opposing this force. And this force is called frictional force. Got it?
Yes, sir.
One minute. So now, on this, because see, why the frictional force has kept? This body is touching this body. And there are two forces acting because of this touching. What are the two forces acting? One is frictional force, another one is normal force. See, these two forces have come by this body is touching this body. ಏನ ಈಗ ಹವಾದಾಗಿದ್ದಾಗ this is not touching, so there is no friction and there is no normal also. ಈ normal friction ಯಾಕೆ ಬಂತ? This body is in contact with this body. Got it?
Yes, sir.
Hello?
Yes, sir.
Yes, sir.
So now there is a frictional force acting and there is a normal acting. So I will now represent this body like this. So what are the two forces acting on the body? Frictional force and normal force. Got it?
Yes, sir.
So what are the two forces acting on the body due to contact? What are the two forces acting on the body due to contact? Normal force and frictional force. What is the net force acting on this body? Two forces are acting. How will you calculate the net force? ದನಗಳು ಈ ತರ ಮಾಡಿದ್ನಲ್ಲೇ ಇಲ್ಲಿ ಮಾಡಿದ್ನಲ್ಲ ನೆಟ್ ಫೋರ್ಸ್ ಮತ್ತೆ ಹೇಳಕ್ಕೆ ನಾ ಹೇಳ್ಬೇಕೇನೆ ಎಲ್ಲ ತಗೋ ನಿಂಗಲ್ಲಿ ಎಕ್ಸಾಮ್ ನಾಗ ಹೆಲ್ಪ್ ಕೊಡ್ತಾರೆ. ಸೊ ಯು ಡ್ರಾ ದ ಲೈನ್ ಪ್ಯಾರಲಲ್ ಟು ದಿಸ್. Got it?
Yes, sir.
दो फोर्सा बा एक ऐसा व्हाट इज द नेट इफेक्ट? नेट इफेक्ट ऐसा ठीक है नहीं? So this force is the net force and this force is called contact force. मालूम अभी contact force?
Yes, sir.
हाँ ये बुक ना का बराबर ये बुक ना का contact force है.